All right, good day, people. Today in this video, I'll be looking at the classification of fruits and how we can classify our day-to-day fruits we eat. And those of us carry doing botany in school or doing biology in school, this video will also help you to classify fruits. So quickly, I'll be classifying fruits in a very simple way, the way it is classified or the way it has been proven generally to classify fruits. Okay, now first of all, what is a fruit? A fruit is actually a fertilized ovary, a fertilized ovary, or a fertilized ovary and other floral parts. Usually a fruit, a fertilized ovary or a fertilized ovary and other floral parts. Okay, and if you know the ovary is the part of the female, is the part of the female part of the flower. The female part of the flower, the female garment of the flower. Is usually the gynecium. So the ovary is one part of the gynecium. So when the ovary is fertilized, it becomes a fruit. When the ovule is fertilized, it becomes a seed. So quickly, to save long stories, fruits can either be false fruit or true fruit. Okay, fruit can either be a false fruit or a true fruit. Now, what is a true fruit and what is a false fruit? A false fruit is a fruit that is gotten from other floral parts. So, when a fruit is not a fertilized ovary, or rather, when a fruit has other floral parts attached to it, those other floral parts are usually referred to as a false fruit. Okay, while a true fruit is a fruit that is obtained from a fertilized ovary. Now, some other term I have to add to it is a parthenocarpic fruit, like the banana, Musia sapientis and Musia parisidiaca, banana and plantain. Okay, a parthenocarpic fruit is actually a fruit that is gotten from an unfertilized ovary. So when an ovary is unfertilized and a fruit develops, we get a parthenocarpic fruit. Okay, while false fruit is a fruit gotten from a fertilized ovary, but other floral part of the fertilized ovary is the false fruit, while a true fruit is the fertilized ovary itself. Okay, now having known that, this true fruit or false fruit can be classified into three. So either of these fruit can be simple, aggregate, or multiple. Usually, the true fruits are best classified into these three classes. Okay, the true fruits are best classified into these three classes. Okay, what is a simple fruit? A simple fruit is actually a fruit that is gotten from a monocarpous pistil. Okay, that means we have to do some explanation. Okay, the female part of a flower is the pistil. Okay, female part of the flower is the pistil. Now, a pistil can have various carpels. Okay, when a pistil has one carpel, the pistil is said to be monocarpous. What are the parts of the carpel? Okay, the part of the carpel is the stigma, the receptive part of the pistil. We have the style, then we have the ovary. Okay, so when a pistil have one carpel, it's said to be monocarpous. When a pistil have two or more carpel, now please watch. Now, but these carpels are fused. So these carpels are fused or they unite to form a single ovary. We say that this carpel is said to be syncarpous. Okay, because we're going to classify fruit based on this basis. Okay, so this pistil or this female part is said to be syncarpous. Remember, it is the ovary that becomes the fruit. That should not be forgotten. It is the ovary so this is syncarpous pistil. Okay, usually many carpel unite to form a single ovary, syncarpous pistil. Then what about the last one? The last one is what we refer to as an apocarpous pistil. Apocarpous pistil is a set of pistils that is not fused. Okay, they are not fused. So let me just do something like this. Okay, these pistils are not fused, they are free pistil. So we have different ovaries, different style, different stigma. So this is an apocarpus pistil. Apocarpus pistil. Okay, fruit can be classified on this basis depending on the type of ovary that gives me the fruit. So when you classify fruit on this basis, we then have a simple fruit, a multiple fruit, and an aggregate fruit. What is a simple fruit? A simple fruit is actually a fruit obtained from a monocarpous pistil, usually a fruit that is one-seeded because it will just have one ovary. Though some ovary can have more than one seed. Okay, so that's what I'm trying to say is that some ovary can have more than one ovule. Remember, the ovule becomes the seed upon fertilization. Okay, so some pistil could have more than one ovule. Okay, so simple fruit are usually one seeded or multiple seeded, but usually they come from a single ovary. They are monocarpous, so they come from monocarpous pistil. Now, what is a multiple fruit? A multiple fruit, I would like to really explain this. Okay, I would like to really explain this after we've known these two. Okay, a multiple fruit is actually a fruit that comes from a syncarpous pistil. Okay, in this type of fruit, many pistils are fusing together to form a fruit. Many pistils fuse together to form a fruit. Okay, so the fruit can be one seeded or many seeded. Okay, but usually it's an aggregate of I'm not like the word aggregate. It's a combination of many flowers, but they are fused to form or they unite to form a single fruit. So many flowers, many floral parts for multiple fruits, many floral parts unite to form a syncarpous pistil and they result to a fruit. So when that kind of ovary is fertilized, it gives us a multiple fruit, a composite fruit. That's why the word composite, many fruits fused together to form one. So composite fruit. So I'll explain how a composite fruit works later. So there are usually two types, sorosis and the syngonium, ones that have syncap. Okay, so I will explain now. What's an aggregate fruit? So sorosis, before I move away from multiple fruit example can be the pineapple. Okay, I have the synconium, the fig, okay? That's the fica monocarpa. So that's from for the fig plant, and they are composite fruits. The aggregate fruits are usually fruits obtained from an apocarpous pistil. So when pistils are um, free pistils, usually many flowers, but they have different ovaries. When these ovaries are fertilized, okay, they form a fruit. A fruit that can obtain from there is the aggregate fruit. Example is a strawberry. Okay, strawberry, the raspberry, okay, and so on and so forth. Those are aggregate fruits. So I'll quickly throw legs on others as we go. So please watch. All right. So the f- for the other classes of fruit can also be classified as fleshy or dry. So fleshy or dry fruit also include these three, but here I will extensively now explain how many of these fruits work. If you see, I have some diagrams of some fruits. Okay, I have the vertical section of some some fruit here. I have some vertical sections of fruit here. I'm going to show you how they look like, how they work. So quickly, I will talk about the dry and the fleshy fruit now. The dry and the fleshy fruit. So we see how they work. You see how they work. So the dry and the fleshy fruit. You see how they work. Okay. All right. So dry fruits and fleshy fruits. Remember, we'll come back to talk about multiple fruits and basically multiple fruits again. So I would like to let you see how this dry fruit works and fleshy fruit. So I'll kick off with fleshy fruit. I'll kick off with fleshy fruit. Okay, fleshy fruit. Now, this fleshy fruit and dry fruit is actually a classification of fruits based on their fruit wall. So the ovary has a wall. So when the fruit becomes mature, or when the ovary becomes mature after fertilization, it gives us a fruit. So we normally have the ovary wall. So the ovary wall is what results to the fruit wall. The fruit wall is referred to as the pericarp. When a fruit has any part of its pericarp, any part of the fruit wall fleshy, it is said to be a fleshy fruit. And this part of this pericarp can be divided into three. So this pericarp is the fruit wall, and the pericarp can be divided into three. So we have the epicarp, which is the outermost part of the pericarp, outermost part of the fruit wall. We have the mesocarp, which is the intermediate part. We have the mesocarp, intermediate part, and we have the endocarp. Endocarp. Now, knowing this fully well, knowing this fully well, fleshy fruits that we have can include the first one. I'll look at a berry. All right, a berry is actually a fleshy fruit that all these parts are fleshy. So all these parts, the epicarp, mesocarp, endocarp, are succulent or fleshy. Many call pome a type of berry. Yes, there are many other types of berry, but I will explain. So epicarp, mesocarp, and endocarp are all fleshy for berry. Now, and it should be noted that berry can be one-seeded. That means berry can be one-seeded, usually from a monocarpous pistil, or some berry are from syncarpous pistils. Okay, so but basically most times they are one-seeded or sometimes many-seeded, and they are usually from a monocarpous pistil. So sometimes they're also from syncarpous pistil. Okay, so example of berry includes the orange, okay, the purple, the orange, the purple. Um, we have the first fruit, not really a first fruit, the guava, Sudium guavaja. So the guava, which is Sudium guava java, yes, guava java, Sudium guava java. That is the botanical name for guava. So that will not be necessary. Just quickly, let's look at it. Okay, now for the guava, for these guys, sometimes these berries are usually from inferior pistils, and some of them are usually from superior pistils. Now, what's an inferior ovary? An inferior ovary is actually an ovary that is above other floral parts. An ovary that is above other floral parts, while an inferior ovary is an ovary that is embedded in other floral parts. Usually, the ovary is inside the receptacle. So, you have to have an idea of flowers before you look at this also. So if you have an ovary like this, let's say an ovary like this, so the pistil, the ovary is inside other floral parts. This kind of ovary is said to be inferior. It's usually inside the receptacle. So that's where the guava fall into place. While the orange and the purple are usually from superior pistil. Tomato is a berry. Tomato is a berry. Tomato is a berry. So usually when you have epicarp, mesocarp, and endocarp fleshy, usually we call them berries. Now we know types of berries already. Now the next type of fruit I like to look at is the one we call the pome. Now many texts call the pome a type of berry. Okay, but the pome is a little bit very unique. The pome is either one-seeded or many-seeded, but mainly one-seeded. Usually one-seeded, pomogates are usually mainly one-seeded. Especially, okay, these plants, they have they have the fruit inside the receptacle. Usually they are inferior. So example of a pomegranate is apple. Now this is an apple. Now this fleshy part we eat in the apple is usually the receptacle. So all these parts we eat for the apple, usually that are edible, this part is usually the receptacle. Now this is the fruit. Now the fruit is encapsulated. The fruit usually have a capsule. It is encapsulated at so this part usually called the thalamus. The thalamus. So the fleshy receptacle, the thalamus. So the fruit is encapsulated. You can see this is two seeded. Okay, the seed is encapsulated. So here is the fruit wall encapsulated. But this fleshy part we eat. So usually pomes are usually first fruits. So they usually first fruit. They are fleshy. So we can if we want to also classify, we cannot say this is a fruit wall because this is a receptacle. But all part of the plant is all part of the of the fruit is fleshy. So because one part of the fruit is fleshy, many classify pome as berry. But first, pomes are usually first fruits in which they are the receptacle encapsulates the fruit at the middle of the plant. So pomegranate, pears, they are all pomegranates, which are apple, pear, they're usually pomes. Okay, the next type of berry we look at is the purple. Okay, the purple, and lastly the ispiridium. Okay, the purple and the ispiridium spellings. The purple and the ispiridium. Okay, ispiridium. Okay, the cucumber or the sycamore-based species are usually purple. Now, what's a purple? A purple is actually a type of fleshy fruit in which the epicap and mesocap, though they are fleshy, but they form a tough skin. They form a tough skin, making the endocap 100% fleshy and succulent. So, purple are fleshy fruits that have the epicap and mesocap forming a tough skin. This can be seen in pumpkin. Yeah, there's a fruit we call pumpkin, watermelon, cucumber, cucumber. Yes, these are examples of purple. The epicap and the mesocap forms a tough skin, and the endocap is usually fleshy. Purple are usually many seeded, and there's one unique thing I've observed about them. They have parental placentation. So the ovule or the seed are arranged parentally in the fruits. They have parental placentation. Those are purple. Now, many texts confuse purple for Hesperidium. Now, what is Hesperidium? In Hesperidium, this time the epicap and mesocap join together to form what they call a ring. Now, it should be noted that in some purple, the thick skin is formed by only the epicap. In some purple, the tough skin covering the seed or covering the mesocap and endocap is usually only the epicap in some purple. But in Hesperidium, the epicap and mesocap must fuse to form a reed. Yes, they form a reed. A reed. Okay, so many people call it, sir, okay, they form a ring, they form like something like a ring-like structure. Okay, if you have seen, this is usually mainly found in orange. Okay, so orange is more of an Hesperidium than even a berry. So in short, normally orange usually not classified as berry. They are classified as Hesperidium. So berry, I'll just put tomatoes. They usually Hesperidium. Though many call Hesperidium type of berry. Many call Hesperidium type of berry. But note the epicap and mesocap form a reed. Now this reed is not as tough as this skin. So that's why purple and Hesperidium are different. They form a reed. Now this reed is usually elastic. If you've seen orange, tangerine also, lemon. So these guys are Hesperidium, the citrus species. The citrus species. Okay, citrus sinensis, which is orange. All these guys are Hesperidium. All these guys are Hesperidium. Okay. Having known these things, I would like to quickly talk about what they call sorosis. Sorosis is actually a fleshy fruit, but a false fruit. That means sorosis is not from a fertilized ovary. But for us to understand the concept of what a sorosis is, for us to get what a sorosis really look like, for us to see what a sorosis really look like, we have to go back to an aggregate fruit so you can see what a sorosis really look like. An aggregate fruit, pardon me, I said aggregate fruit, a multiple fruit. A multiple fruit is usually a combination or a fruit from many flowers, okay, but they unite to form a syncarpous pistil. I said that already. So now let's look at multiple fruit. Multiple fruit. There are two types of multiple fruit that are very unique. The sorosis, which is a fleshy fruit, if considered based on fleshy and dry. which is fleshy, and we have the synconium, which is usually dry. In some cases, it can be fleshy. Okay, okay, which is usually dry, but it does not release its does not release its seed upon maturity though. Okay, now but psoriasis and synconium. Now psoriasis is my own concern. Psoriasis, example of psoriasis is pineapple. Okay, now pineapple. Now what happens to psoriasis? In psoriasis, they are the in psoriasis, for instance, this pineapple. Now this is the carpels. So they're usually for many flowers. So you see a clusteration of the carpels. The petals upon maturity must have withered. The petals of this pineapple upon maturity must have withered that's upon the formation of fruit must have withered off. Now this is the carpel. So many carpel. So the fruit is supposed to be around here. So this we eat on the pineapple is usually the receptacle. So a psoriasis have the fruit is not well developed, or the ovary is not well developed. It has a constellation of carpels at the top. Now the fleshy and edible part is now the receptacle for psoriasis. The fleshy and edible part is now the receptacle. Now this receptacle has no seed inside. It has no fruit enclosed in it, no fruit, no seed enclosed in it. The which is many says that the fruit, or rather the fruit must have is not well developed, so it withers also. So the ovary of this fruit is generally not well developed, so it withers with time upon maturity. Okay, so but this is the pineapple psoriasis. So this part is also fleshy, and it has some remnants of some floral part at the side, the remnant of some floral part. If you have seen a pineapple, usually some remnant of the floral part at the side. So that is usually how a psoriasis look like. So it's usually fleshy, but a that is fleshy fruit that is um a first fruit, and it's actually a receptacle. Now, the difference between this receptacle and that of apple is this: the apple receptacle encloses the seed, but for psoriasis, the receptacle has nothing in it. There's nothing in the receptacle, and usually this is usually not a multiple fruit. Usually a simple fruit. This apple is usually one seeded, usually a simple fruit. Just the fruit is enclosed inside the receptacle. The fruit is encapsulated inside the receptacle. But this is usually a multiple fruit constellation of flowers to form a single ovary, which should have been somewhere here, but not what developed. Already explained. So that's for psoriasis. Usually, many classify psoriasis as part of fleshy fruit. Now, what about the synconium? Now, the synconium is actually for example of synconium is the fig. The fig, okay, the ficus monocarpa. Okay, ficus monocarpa, that's the botanical name, ficus monocarpa. Okay, now the fig plant is actually very unique. Now why is it unique? Now it's just like the psoriasis. Usually it's from a clusteration of carpels, so usually they have many carpels at the top of the plant. Okay, just that it has something very unique. Okay, for psoriasis this might be the branch of the plant. Now you see the receptacle. Okay, this is the receptacle. Now, but this is the difference. For psoriasis, the fruit is inside, forms a holo in the receptacle. So the fruit forms a holo in the receptacle, and you see other floral parts. So this is the scale, and this can result in the carpels and so on and so forth. So in synconium, the seed or the fruit forms an holo inside, okay, inside the receptacle. But for psoriasis, it does not form any halo. So in psoriasis, usually no seed in the receptacle. But for synconium, there's a seed inside the receptacle, which usually grows out as scale. So the fruit does not, which usually extend out to other flower part as scale at the tip of the receptacle, or at the bottom, at the entrance of the receptacle. So the receptacle usually has an opening at the end, which some plants, or which rather some the flower part can extend. Okay. So if this is a fruit actually, so usually from a fertilized ovary too. So this is the fruit inside usually from fertilized ovary. This fruit inside could be one seeded or many seeded, as the case may be. It can be one seeded or many seeded, but usually the fruit forms an holo. So you get an holo inside the receptacle. That's also very unique about it. Okay, so this can be other floral parts where the pollen grain falls and fertilize the ovary. Okay, and so this is a synconium. So that's the difference between synconium. In synconium, the fruit forms an holo inside the receptacle, but in psoriasis, there's no hole inside the receptacle. So it's just have a fleshy receptacle which is edible. Okay, fleshy receptacle which is edible. So that's the main difference between synconium and psoriasis. Main difference between synconium and psoriasis. So I'll quickly talk about dry fruit quickly. I'll quickly talk about dry fruit. Okay, so dry fruit. So usually very technical, dry fruit. All right, guys. Dry fruit can be of three types. Okay, dry fruit can be of three types. I have the dry dehiscent, the dry indehiscent, and the schizocarpic fruit. All right, so let's quickly dive into it. I have some examples on the board here, so which I can use to explain for you. So we're going to talk about the dry dehiscent or indehiscent. Okay, let's indehiscent, dry indehiscent. Dry indehiscent fruit. Now, what are dry indehiscent fruits? A dry indehiscent fruit is a fruit that, upon maturity, the pericarp or the fruit wall is dry, and indehiscent means that it does not open up to release the seed. So it is a dry indehiscent fruit is a fruit which is dry, or the fruit wall is dry upon maturity, and does not open up to release the seed upon maturity. So it does not open up to release the seeds upon maturity. Those are dry indehiscent fruit. Now, dry indehiscent fruit includes they include achene, they include a cryopsis. So you see the difference now. They include a samara, okay, and they include a cypsella, and they include nuts. So quickly, what is an achene? What is an achene? Let me see if I have an achene on the board. Yes, I have an achene in the case of sunflower. Yes, in the case of sunflower. An achene is usually a one-seeded dry indehiscent fruit that does not open up in maturity. For a monocarpous pistil, it is one-seeded. Example, sunflower. So inside this fruit is a seed, just one seed. That's an achene. Inside of it is a seed, just one seed. That's an achene. Okay. Um, Achenes can have type. I usually have two types of achene. Usually the cypsella and the samara. They're usually classified as types of achene. Why? The samara, for instance, or rather the cypsella, let's take samara first. The samara, for instance, is usually a one-seeded achene in which the fruit wall, that's the pericarp now, which is dry, have some wing-like structure which can enable the fruit disperse from one place to another. So a type of achene, one-seeded dry in the insect fruit, in which the fruit wall have some wing-like structure for dispersal, is referred to as a samara. Is referred to as the Samara. An example is Combetrum. Now, Combetrum, this is a one-seeded, this is like an achene, similar, but now the difference is the pericarp, the fruit wall, has some wedge-like structures that can help these plants disperse or help these plants flow easily in presence of wind. That is a Samara. So Combetrum is an example of a Samara. So another type of achene is a Cypsella. Now a Cypsella is usually very unique as we see them in our environment. Here in Africa, we call them the Edede plant. Okay, we call them the Edede plant. But now this plant I usually have the usual plant. Actually, let me explain. Now, this plant usually this plant or this fruit usually they are types of achene first. Now, since they are type of achene, they have a persistent callus. So that means this fruit, this cypsella, other floral parts such as the receptacle and co, will all wither off away from the fruit, but the callus will not wither off. We say the callus is persistent and form a airy-like structure or a airy-like parachute called pappus. A airy-like parachute called pappus. So, who is forming the airy-like parachute called pappus? The callus. And this callus can help in the dispersal of the seed. So, this is a tridus. So, an example is a tridus. So, this tridus is an example of a sapsella. This is a tridus. So, this wing-like structure you are seeing, this wing-like structure, this is called the airy pappus. This is the airy pappus. And this airy pappus is usually formed from a persistent callus. So this is the fruit, a one-seeded fruit you are seeing below the airy like what's it called? Below the airy pappus. So this is the airy fruit wall, and this is the seed in it. So that is a sapsella. Usually very self-explanatory. Sapsella. Now I'll quickly talk about having known the sapsella, I'll quickly talk about the caiosis, or rather the knot. Many people also call achin knot types of achin, but I don't refer to as knot as type of, I don't refer knot to as type of achins. Now, a knot is a superior or it developed from the superior ovary, a ovary that is above other floral parts, just above the receptacle. If you have seen a cashew, if you have seen a cashew plant before, you see a knot at the bottom of the cashew plant. So you see a knot. Okay, so the cashew nut is an example of a nut. The groundnut is not example, it's not an example of the nut. So groundnut or peanut is not an example of a nut. They are called legumes or the pods. So now this nut usually is a one-seeded dry indehiscent fruit. Just that the pericarp or the fruit wall is woody. So a woody dry indehiscent fruit, a one-seeded dry indehiscent fruit that the fruit wall, the pericarp is woody, is called a nut. An example is the cashew nut. Cashew nut. Now, for cryopsis, a cryopsis is actually what we call grain, usually called grain. In this type of fruit, the fruit and the seed are indistinguishable. So the seed will be inside the fruit without us knowing. In short, we confuse the seed for the fruit. An example is Z maize, which we call maize or corn in Africa. It's called worldwide. Or now Z means we have the oriza, the grass, the oriza grass, which the rice is more important. Oriza sativum, which is rice. So the Z maize and the oriza. So they are examples of caiosis. Now, we'll say that in caiosis, the fruit wall, the pericarp, fuses with the seed coat. So the seed is fused with the pericarp in a way that the seed and the fruit are indistinguishable. Such type of dry indehiscent fruit is called an achin. So in most cases, they are one-seeded from a monocarpous pistil. So that is the breakdown of dry indehiscent fruit. So look at them. Look at them. I know you might be wondering now that they are a little bit technical. So just look at it. Look at it. It's not very difficult. As I look at the dry dehiscent fruit, okay, the dry dehiscent fruit. So this is the dry dehiscent fruit. Wiping them off. So don't forget, if you're enjoying the video, make sure you hit the subscribe button and hit the notification button so we alert you when a new video drops. Or if you want to make a video request, you can just quickly request that on the comment section. So if you have anything to say, any correction, there's something I don't like about the video, the comment section is all yours. So we're going to look at dry dehiscent. So dry, my spelling of indehiscent was not correct. Dry incense. No, it's indehiscent. Now I want to look at dry dehiscent. Dehiscent first. So dry indehiscent, just to put in front of the, so dry dehiscent. What's a dry dehiscent fruit? A dry dehiscent fruit is a fruit that the fruit wall upon maturity opens up to release the seed. A fruit in which the fruit wall upon maturity open up to release the seed is referred to as a dry, is referred to as a dry dehiscent fruit. Is referred to as a dry dehiscent fruit. Okay, dry dehiscent fruit usually have some types. Dry dehiscent fruit usually have some types. and they are usually of 4 or 5. I don't know. So let me just list them. So the first one, orderly, follicle. We have a follicle. We have legumes. We have capsule. We have the capsule. We have the siliqua or the silic. Okay. We have the siliqua or silic. Okay. Then so if E there's silica, and then basically these four. So capsule, legume, and the silic or the siliqua. Okay, legume, follicle. All right. So how do these guys look like? What's a follicle? A follicle is a type of a dry dehiscent fruit that is usually one-seeded, that release that split up upon one suture or one part. So upon maturity, it opens up like this. So upon maturity, it just open up like this and release the seed. So upon one part, they split up upon one axis or upon one suture at maturity to release their seed. So example is the kola nut. Yes, example is the kola nut. The kola nut, the kola SPP. So example is the kola nut. Yes, example is the kola nut. That's an example of a follicle. Then another type of follicle is a legume. Now legumes are also called pod. Okay, you must have been thinking of, you are thinking of pod, you must have seen the groundnut pod, the peanut pod. Okay, those are examples of legume, the pride of Barbados, the crotillara. So those are examples of pod. So what do the guys do? So upon maturity, they split up upon two structure. So if this is them upon maturity, they split up on front and back. Yes, split up front and back. If you have seen a peanut or a granite, you can open it along two sutures. So they split up upon maturity along two sutures to release their seed. Those are examples of legume, the peanut, the um, the peanut, the cowpea species, pride of Barbados, crotillara or crotallara. So those are examples of pod or legumes. Now, capsule. What's a capsule? A capsule is actually a dried insect food that split up along 2 or 3 parts. So they usually split up along two, 3 or more parts. Upon maturity, this open up upon around 2, 3 or 4 sutures, usually two or more. When I say two or more, upon maturity, to release their seed. So upon maturity, they split up along 2 or 3 sutures to release their seed, and they are very very popular in Africa. Here we have the castor, and the okra. We have the castor and the okra, and so on and so forth. So these are okra. Yes, the ebemuscus esculentus. That's the okra. Now, if you see the okra, it's usually split up along many. Usually, first of all, the okra is many seeded. Usually an apocarpus pistil, apocarpus pistil in many cases. So it has many seeds. It's many seeded. Okay, but the pistil is not really necessary now. So now this is many seeded. This is many seeded. It split up upon maturity to release. It split up upon more than 2 lines, So like two, three, 1, 2, 3. This is 4. More than two, 3 and above in most cases to release this seed for maturity. So those are examples of um, capsule. So like the castor oil we know is actually a plant that dispatches the seed by what we call explosive mechanism. Okay, it shoots its seed when it's upon maturity, but it splits. The most important part is that it split along many parts, or split along many walls of more than 3.